Hello everybody, I am Ashish Kumar Vasisht and on the platform of PRAYAS KSG, I welcome you all. Now the topic that we are going to discuss is ozone layer and ozone layer depletion. Now, you know very well that ozone layer is present in stratosphere. And if we talk about the extent of ozone layer in stratosphere, the extent of ozone layer in stratosphere is roughly about 15 to 50 kilometers. So that's the stretch that we can find of the ozone layer in stratosphere. Now, what we can say is ozone is not naturally present, but is generated, and is generated by the impact of solar radiation on the oxygen present in stratosphere. What happens is that oxygen, when it is present in stratosphere, the solar radiation falls on it, and this oxygen molecule would be breaking or splitting into oxygen atoms. Now, this reaction under the influence of solar radiation is called as photolysis. We can see also that this oxygen atom would again recombine with oxygen molecule to form ozone or O3, and this oxygen ozone cycle, which takes place continuously, is referred to as the Chapman cycle. Chapman cycle. Now, when we talk about ozone layer, in a stereotyped way, what you have learned from your school days is that ozone layer is present in stratosphere. It is responsible for filtering UV radiation. And if suppose ozone layer depletion takes place, then UV radiation would be reaching the surface of the earth in abundance, and that would be responsible for diseases like skin cancer or cataract. But what we can say is that as far as UV radiation is concerned, there are three distinct types of UV radiation. And first kind of UV radiation is called as UVA. Now, suppose this is the ozone layer, O3, which is present in stratosphere, and this is the surface of the earth. We can see that ozone layer is not responsible for obstructing UVA radiation. So UVA radiation reaches the surface of the earth. Naturally, it reaches the surface of the earth and won't be hindered by the ozone layer. What we can say is that the lambda, that's the wavelength of this radiation, is from 320 to 400 nanometer. But when it is reaching the surface of the earth, it would be responsible for certain adverse impact. And the adverse impact for which it is responsible is aging. Aging takes place in humans much earlier, and the reason behind it is that the elasticity of the skin, gets reduced. Now, this is not a matter of concern for us, because it is reaching the surface of the earth, and it is reaching the surface of earth naturally. Now, our matter of concern is what? Our matter of concern is the second kind of UV radiation, which is called as UVB. And if suppose this is O3, ozone layer, and this is the surface of the earth, what we can see is UVB radiation would be responsible for reaching the surface of the earth minimally. And if we see the lambda of this radiation, the wavelength of this radiation, the wavelength is from 290 to 320 nanometers. That's the wavelength. And if at all it reaches the surface of the earth in abundance, it would be responsible for diseases like skin cancer. It would be responsible for diseases like cataract. The adverse impact also includes damage to the immune system. The adverse impact also includes damage to nucleic acids. But we can see that UVB radiation is our main concern in the limelight of depleting ozone layer. The third kind of UV radiation is called as UVC. And if suppose this is the O3, ozone layer, and this is the surface of the earth, then we can see that UVC radiation never reaches the surface of the earth. And if at all it reaches the surface of the earth, it would be doomsday for mankind, because this UV radiation is directly responsible for tissue damage. And if we see the wavelength of this radiation, the wavelength of this radiation is roughly about 100 to 290 nanometers. Now, what we can gauge from these three figures, what we can gauge from these three types of UV radiation, what is that energy is inversely proportional to wavelength. because the wavelength is getting decreased and more energetic is the UV radiation. because it is responsible for more and more of damaging impact. Now that's first. If suppose they ask you that in the limelight of ozone layer depletion, which UV radiation is a matter of concern, then it would be UVB. And if suppose they ask you that from which UV radiation the ozone layer protects us from, it would be B and C. But on the other hand, a subjective question also can figure that suppose if they ask you that ozone is also present in troposphere, but then, sorry, oxygen is also present in troposphere, but then ozone layer is only and only confined to stratosphere. Why that happens? Now there are three reasons behind it, that why ozone layer would be only and only present in stratosphere and not present in troposphere. Now the first reason behind it is what? That if we see the temperature in stratosphere or the temperature in troposphere, in stratosphere, if we move upward, the temperature enhances. But in troposphere, if we move upward, the temperature reduces. So what we can see is there would be less of convection, there would be less of mixing of air in stratosphere when compared to troposphere. And as a result of which, what we can see is that the layers of stratosphere are more and more stagnant in nature. And that's why it's called as stratosphere. So that's the first reason behind it. The second reason behind it is what? That when we talk about the intensity of UV radiation or the solar radiation which is reaching the troposphere, it happens to be less when compared to stratosphere, and that's why the intensity is not as high for photolysis. So that's the second reason, that the intensity of solar radiation in troposphere happens to be less for photolysis. And the third reason behind it is what? The third reason behind it is that when we compare stratosphere with troposphere, we can find that stratosphere happens to be a dry region. On the other hand, troposphere is responsible for holding moisture. And as far as ozone is concerned, ozone always happens to be unstable for moisture. So these are the three reasons why we can say that ozone is confined to only and only stratosphere but is not present in troposphere. If suppose another kind of question is asked from this segment, that when we talk about ozone layer or ozone, the presence of ozone on account of its location can be both harmful as well as beneficial for mankind. Now certainly, if suppose it is present in stratosphere, it would be beneficial for mankind as it is responsible for filtering the damaging UVB or UVC radiation. But when we talk about the troposphere, when ozone is present in the lower part of troposphere, certainly it would be acting as what? It would be acting as a pollutant. What we can see is that ozone already has been included as one of the indicators among the 8 indicators in the National Air Quality Index of India. So it is considered to be a pollutant. On the other hand, when we talk about the industrial emissions which are responsible for emitting in the atmosphere volatile compounds or nitrogen oxide, due to the impact of solar radiation, what happens is ozone is manufactured or ozone gets generated. And this would be harmful for mankind if suppose we are exposed to ozone for 1 or 2 hours. There would be respiratory problems or other also types of illness. On the other hand, we can see also that as far as ozone is concerned, ozone is also responsible for corrosion of buildings. So damaging impact on the buildings can also be seen. So as such, and one more thing, that ozone is also part of photochemical smog. So on account of its location, ozone can be both damaging as well as beneficial for mankind. Now there's a brief description of the ozone layer today. I hope you understand. When we meet next time, we will be discussing further. Thank you very much.